Circular Motion 3. Introduction. You have already examined centripetal acceleration, but there is no acceleration without a corresponding force. You are now going to learn about centripetal force. Centripetal force explains how to turn an aircraft, why some motor racing circuits are banked, and how you get round the loop of a roller coaster. In this lesson, you will learn the equation for centripetal force, use it in a range of examples. You need the force with you because if it goes, so do you. But which way? Click play button to start the active turning.
Okay, so the athlete release the hammer. Which way will the hammer move? Click on the correct arrow.
When the hammer thrower stops, select the correct arrow to show the direction the hammer will travel in. If you have got it right, the animation will continue to show what happens.
Okay, so that means just now the athlete is turned in a clockwise direction, right? So that means once it's released here, it will move this direction. No, that means that it will move in this direction.
Click next to move to the next scene. Click play button to start the car moving, and then select the correct arrow to show the direction the car will slide in.
Okay, now the car is moved in anti-clockwise direction. If the car lost control and skid here, which direction this car will go to? So that means it will move in this direction when it is when the car is lost control.
Move on to the final scene by clicking the next button and repeat.
Okay, now look at a satellite is orbiting the Earth.
The force which keeps objects on a circular path is called the centripetal force. In which direction does this force act?
So now the force which keep the object on a circular motion is the centripetal force. What is centripetal force? The centripetal force is the force keeping an object moving in a circle. It is directed towards the center of the circle and perpendicular to the direction of the motion. So this means that this is the centripetal force. Okay, for this part. Okay, so now if this satellite, okay, free from the, just now it's turning, right? Turning because of the centripetal force pulling on the satellite. Now, if the centripetal force suddenly disappear, that means that this satellite will move in this direction.
Answer: towards the center of the circle.
Okay, centripetal acceleration is towards the center of the circle.
You are now going to start working out the equation for centripetal force. To give you plenty of time, you will be following a snail's progress.
Okay, so now if look at here, force. Okay, so is there any? Okay.
Select the correct quantities from the drop-down menus to complete the equation.
Okay, force is equal to, as we know that force is equal to ma, right? If the m, what we can choose, okay, let's say we choose the highest a, okay, 0.05 times with the 0.005. So that means how much is it? If the m is 0.05 times with the acceleration of 0.005. So we get that it will be 0.00025. Okay, so is it correct? Yes. Okay.
When the equation is correct, you will be able to select some values for the two quantities which might be appropriate for the snail.
Okay, so now
Type
we
your
check the answer
in
already.
calculation in the box and click correct button to check your answer. Why does this equation seem to have nothing to do with the snail's motion?
Okay, why does this equation seem to have nothing to do with the snail motion?
Answer: the snail does not seem to be accelerating.
Okay, because there's no difference, okay, no acceleration, so this means no force.
Why is the snail accelerating?
Okay, why is the snail accelerating?
Answer: because it is moving in a circle.
Okay, now if the snail move in a straight line, that means no acceleration. But if the snail move in a circle, there will be an acceleration. Okay, they didn't mention what type of the acceleration, yeah, but this means that there will be an acceleration involved in the motion.
What sort of acceleration is it?
What sort is it?
Answer: centripetal acceleration.
Centripetal acceleration. Now the snail move on a plane surface. It's moved in a straight line with constant speed. For example, constant speed or constant velocity. Let's say constant velocity, easier. Okay, so this snail now move in a circular motion with a constant speed. Let's say constant speed also or constant velocity. There is no change in the velocity, no change in the speed when it's moving in circular motion. But that means no change in velocity, no change in the displacement. That means no acceleration, right? No acceleration to accelerate it to in the circular motion. But there is an acceleration always point, always at to the center of the circle. That is the centripetal acceleration.
Select the correct quantities from the drop-down menu to complete the equation.
Okay, so this means that it should be m. So what is that? mv squared over the radius. Let's say mv squared over the radius, okay, 0.03 mv, that is times with 0.001 square over the radius is equal to 0.1. So wow, very big. So this one we make it, okay, if divide, okay, how to make it smaller, huh? Let me see, is it anything? Okay, no leh. So this means, okay, so this will be, okay, no point, we must use times with square divide by 0.3. So that means it will be 0.2345671. Okay, so that is the answer. Okay,
This equation is really the same as the previous one. Why?
okay, why is same with the previous one?
Answer: it is still F equals ma, but a is replaced by the equation for centripetal acceleration.
Okay, now the A is not the acceleration for this one, but to the center of the circle.
Select some values for the three quantities. Type
Okay.
your result and
So
click
this one we
correct
already
button
checked, yeah?
to
We
check
skip.
your answer. The equation above is the equation for centripetal force in terms of velocity.
So the equation that is mv square, m times with the v square over the radius over the r.
What would the equation be in terms of angular velocity?
What would be the equation in terms of the velocity? So this
Answer.
means that
F equals m omega squared r.
so this means that F is equal to ma, right? A is the acceleration. Acceleration will be omega square r. Okay, omega square r. So that means that this is the formula we will use to solve. That is m equal to m omega square r.
Summary. A force is necessary to provide the centripetal acceleration required for an object to move in a circle. A failure of the force will allow the object to move off at a tangent to the circle. The force is directed towards the center of the circle. The force is known as the centripetal force. The equation for centripetal force in terms of velocity is F equals mv squared over r. The equation for centripetal force in terms of angular velocity is F equals m omega squared r.
So how important is the centripetal force to obtain an object move in circular motion, to obtain a car or a vehicle that turn at the corner?
Select the correct force from the first drop-down menu to supply the centripetal force in this case.
Okay, select the force. What type of the force is it? Centripetal force. So let's say select the correct force from the first drop-down menu to supply the centripetal force. Centripetal force here, which is the force? That means that the force will as a friction.
Next, select a value for speed.
Speed, let's say starting with 5.
Then select the correct value for centripetal force.
Okay, so mv square over r, this means m is 1000, v is equal to, okay, how much is it? V is 5 square over r. Okay, what is the radius? Radius is equal to 20 meter. So from here, we get that the centripetal force is equal to 1250 Newton. Okay.
Click correct button to check if you have got the right answer.
Okay, so that means that we notice that
to the car.
maximum centripetal force available is 6,000, right? But now the centripetal force, okay, used to pull the car just need to obtain the car move in the circular motion. That means follow the curve, follow the corner is 1250 Newton only. So that means still no problem, right? If I increase again, okay, if I increase to the speed to 10, okay, so what will be the centripetal force? That means that 1000 times with the, okay, speed divide, okay, speed is 10 square. So how much is it? So now it's equal to 5,000. So what happened? The car still can move, follow the path. If the speed increase to 15, okay, that means that it will reach to 11250. Correct or not? We calculate again until 15. Okay, mv square over r. So we get that 11250. So what happened? Now we notice that 11250 is greater than 6,000 Newton, right? If it is greater than 6,000, that means the maximum centripetal force available for the car. If the centripetal force needed more than the 6,000, that means the car will lose control. Okay. What happened if with greater speed? That means greater speed, 20,000, much more than the 6,000, the allowed or maximum centripetal force available. So what happened? The car will skid away as well.
What factors determine whether the car will make it round the corner or not?
So what factor?
Answer. The car will make it as long as the centripetal force required is not greater than the frictional force.
So that means that this 6,000 Newton maximum centripetal force that actually is come from the friction of the car. The friction force of the car is come from the contact between the four wheels and the surface of the rod. So that means that how important is the frictions on the wheels with the surface of the rod to provide a centripetal force to allow a vehicle to move in circular motion.
Here, you have the back view of a car going round an oval track with flat straights and banked curves.
So now we notice that if the car is moved on a plane surface, that means that they will just have the mg only. Okay, later, yeah. So now mg, which have according to the Newton's third law, there will be a normal reaction. If the rod, the surface of the rod incline with any angle, okay, later incline with any angle, that means that what happened? It will have an r sin delta and also r cos delta, where the normal reaction of the car will slightly shift. Okay, you see? Okay, so now
look at the forces acting on the car as it bangs round the curves.
So that means that
R.
So what is the R? R is the
Answer,
normal reaction
force. What provides the centripetal force when the car is banking? Answer, the horizontal component of R sine theta.
You see now, no force point to this direction, right? That means that if the car is turning, okay, it's turning with an angle of 26 degree incline. So that means they will have another force. If the rod not inclined, now inclined, right, with angle of a certain angle, that means it will provide an r sin delta. Okay, when it's turning at the corner, if the rod is inclined a bit. If turning at the corner, the vehicle turning at the corner without any inclined angle, that means that it will not have any r sin delta. Observe that when they without any inclined angle, no r sin delta, right?
What is the advantage to the car driver of the banking?
What is the advantage?
Answer, it allows a higher speed than would be the case for friction alone.
So that means that the car can turn with higher speed.
This time, you have a plane, but it is very similar to the car in the last example. Select the correct force from the drop-down menu.
Okay, ladies and gentlemen, when an aeroplane turn left or turn right, or turning take a corner, take a turn, that means that it's the body of the airplane will slightly incline with certain angle. So now select the force. What is the centripetal force given by? Okay, so is it friction, tension, reaction, electrostatic force? No electric field here, right? So no electrostatic force. Okay, is it any magnetic force? Okay, no. Lift force, maybe. Okay, gravity, yes. There is a gravity force involved. There is a lift force involved. Friction, a friction. Is there any tension? No, because the airplane is not tied with applied with any rods.
Calculate the centripetal force needed and select your answer from the menu.
So here the centripetal force will be the lift force. The centripetal force given is come from the lift force. That means that come from the lift force. Okay. So now the radius. Okay. So here now mass is equal to 2000, right? Curve with 5000 meter. Okay. And the speed is 150 meter per second. So the centripetal force needed is equal to 600 Newton. So this means that, okay, sorry. So we need to calculate how much is it. Still using the m radius, mv squared over r. If the lift force is the mg. So now the centripetal force will be L sin delta. L now you see L is come from the mg, right? Because mg is equal to L cos delta. So that means that this will be okay. So now let's check. Yeah, we calculate the L. Calculate this one. L sin delta. Okay, L is equal to mg. Okay, so that means that mg sin delta. Let's see, mg 20,000 times with 10 or 9.81. Okay, times with sin. Okay, angle of banking. Let me see. Okay, that means sin delta is equal to 0.45. So that means this will be at 290. That means 9,000. Okay, 9,000. Still incorrect. What happened? Okay, let me use mv squared over r. V square over the radius is 5,000. Okay, so correct. mv square over r, that means that with any angle, without any angle. Okay, so that is 90,000. mv square over r is 90,000. So that means that times with, okay, sin for times with the angle, it becomes 40500. Then what happened? Let me check. We try one by one. $90,000 also wrong. 666. Okay, so this means that this angle, we should find out the angle, right? This angle, if not wrong, okay, sorry, should be 45 degree. 45 degree, this will be should be mv square over r. mv square over r is equal to, okay, we need to find out the angle. Okay, understand? So this one, we use mv square over r, we get that. Okay, 90,000 is the centripetal force needed. Centripetal force needed. Okay, so that means that it will be equal to mg sin delta. So from here, okay, what would be? Okay, I take out my pen first. Okay, so from here, like this. If I use the mv square over r, so this, all the value put in, I will get that it will be 90,000 Newton. That is a centripetal force needed. So this 90,000 Newton, okay, mv square over r is equal to L sin delta. Okay, so if L sin delta, L is equal to mg. So that means 90,000 is equal to mg. M is equal to how much? Okay, so 20,000 times with 10 sin delta. So sin delta equal to how much? So that means that it will be 90,000 divided by 20,000 divided by 10. Let's say I use 10 now. So this means that I get that this should be, sin delta should be 0.45. 0.45 correctly. Why wrong? Okay. Okay, let me see. Sin delta equal to 0.45. If shift sin answer, okay, we get that it will be angle is equal to 26.74 degree. Okay, angle is it 26.74 degree? Okay, so that means the nearest 24.66. Okay, so that means that here we should not use 10. Maybe we use that. Okay, this should use 9.81. We try to use 9.81 and see how much is it. Yeah. Okay, now if I use 9.81, that means that 90,000 divided by 20,000, okay, divided by 9.81. I get that 0.45 at 7, 0.45 at 7. So shift sin answer. So I get that around 27.3. If 27.3, okay, that means the nearest still something like that. Okay, this still 26 something, 24, 26, 27, 26, 27. Okay, so now from here, okay, what we can conclude, you see, mv square over r radius is equal to mg sin delta, right? So this means m actually can cancel. So v square over rg is equal to sin delta. This will be the formula used. Okay, so the speed of the aeroplane is depends on the r, depends on the angle. Okay, that's all. So that means that we can set that v square, if want to find the speed of the aeroplane, that's turned in the sec. So that means it will be v equal to square root of rg sin delta. If this one is for a car, same thing for a car when turning at the angle. Okay, so that means that it will be RG sin delta. Okay, the angle, okay, the angle is from here. Okay, where is the angle? The angle is come from here. Okay, because L equal to L is from initial is here, so it's shift through the left side. Okay. Okay, now let's move to the next slide.
Calculate the angle of banking by following these steps.
Okay, mv square over
What
r,
is mv
we get
squared
9,000.
over r equal to? Answer: L sine theta.
It's also equal to L sine theta.
What is mg equal to? Answer: L cos theta.
Mg is equal to L cos delta, right? Okay, so that means that this will be, okay, L sin delta.
Divide mv squared over r by mg. What do you get?
So mv square over r divided by mg. That means that you see it will be v square over rg, right?
Answer: v squared over gr. Divide L sine theta by L cos theta. Answer: tan theta.
So this means that, okay, here it will become the tan delta.
The results of the two divisions are equal. So what equation do you get thinking theta, v, g, and r? Answer: tan theta equals v squared over gr.
Okay, so to solve the L, so that means that we will get that tan delta equal to v squared over gr. Okay, so that means that, okay, again, yeah, this one we can analyze this by another method. Okay, so this method is like that, mv squared over r. Okay, so actually it's equal to force, right? Mg. So from here, m and this, okay, we okay, this is the first equation, mg. Okay, from this equation, we also notice that L cos delta is equal to mg. Second equation. Okay, so mg first is equal to 2. That means mv squared over r is equal to L cos delta, right? Now L cos delta, okay, here also have the L sin delta, right? Okay, so that means that L cos delta over the L sin delta. This will be the delta. Okay, this means that mv squared over r will be equal to tan delta. Let's go back again to see what happened. Yeah.
The results of the divide L sine theta by L cos theta. What do you get? Answer: v squared.
This one
Divide
is equal to,
mv squared over r by mg. What do you get?
okay, so this one will get that is equal to
v squared over gr.
Okay, v squared over gr, correct? mv squared equal to L cos delta equal to
Divide L sine theta by L cos theta. What do you get? Answer: V squared over GR.
V square over GR. That means that V square over GR is equal to 1.
Divide L sine theta by L cos theta. What do you get?
L sin over cos, that means that it's
Answer:
tan delta.
tan theta.
Okay, why we need to divide by L? So that means that if the force is like that, this is our L, this is the delta, this is L cos delta, that means this is L sin delta. Okay, so that means that delta tan delta is equal to L sin delta over the L cos delta.